2,000 meters below the surface, the sun doesn't exist. Not dim, not filtered, gone. The last photon of sunlight gives up around 200 meters down. Below that is permanent darkness, crushing pressure, and temperatures just above freezing. The pressure at 2,000 meters is roughly 200 times what you feel on the surface. It would collapse your lungs instantly. It would force nitrogen into your blood in ways that would kill you before you registered what was happening. And something is down there. A lot of somethings. Things that have been evolving in total darkness for millions of years. Start with something that looks like it crawled out of a nightmare version of your garden. The giant isopod. If you've ever seen a roly-poly bug, a pill bug, the small gray crustacean that curls into a ball when you touch it, the giant isopod is that. Except it's the size of a football. Some reach 50 centimeters long. They live on the abyssal plain, the flat, dark floor of the deep ocean, at depths between 170 and 2,500 meters. They eat whale falls. When a whale dies and sinks to the ocean floor, giant isopods arrive in numbers and consume it. The carcass of a single blue whale can feed an abyssal community for decades. The isopods are part of the cleanup crew that makes sure nothing goes to waste in an environment where food is so scarce that a dead whale is a once-in-a-generation event. They can also go without food for over 4 years. A captive giant isopod at an aquarium in Japan refused to eat for 5 years and 2 months before it died. 5 years. No food. Still alive. Still functioning. Whatever deep-sea life figured out about survival, it figured out things we're still trying to understand. The barrel-eye fish, Macropina microstoma, lives at around 600 to 800 meters depth in the Pacific Ocean off the American coast. It has a transparent head. Not metaphorically. The entire upper portion of its skull is a fluid-filled transparent dome. You can see directly into its head. And inside that dome are 2 tubular eyes that rotate independently within the fluid. The green barrel-shaped structures you can see through the dome are the actual eyes. What looks like eyes on the front of its face are actually olfactory organs, the equivalent of nostrils. The tubular eyes point upward by default, scanning for the silhouettes of prey above it against what little light filters down from the surface. When it finds something it wants to eat, the eyes rotate forward to focus on the target. We didn't know the head was transparent until 2000. The siphonophore, specifically Praea dubia, and this is where the definition of what an animal even is starts to bend. It looks like a jellyfish. It's not a jellyfish. It's not one animal at all. It's a colony of genetically identical clones called zooids, each one a separate organism, each one specialized for a different function. Some zooids are designed only for propulsion, some only for feeding, some only for reproduction, some only for defense. None of them can survive alone. Together, they function as a single coordinated predator. And the whole structure can reach 130 feet long. Longer than a blue whale. The longest animal on Earth is not a whale. It's not a giant squid. It's a colony of clones that functions as one animal and can stretch the length of 4 school buses end to end. It drifts through the midwater zone, trailing tentacles that can extend outward to catch prey. The feeding zooids digest whatever is caught and share the nutrition through a central canal that runs the entire 130-foot length of the colony. One animal, 130 feet, made of clones. Each clone a separate life form. The whole thing one organism. The deep ocean decided that the rules about what constitutes an individual didn't apply down here. The goblin shark, Mitsucarina austini, a deep-sea shark found in oceans worldwide, including off the American Atlantic coast. It's pink. Not a healthy pink. A pale, slightly translucent pink that comes from blood vessels visible beneath very thin skin. It looks like something that was never supposed to be seen by anything with eyes. But the jaw is what matters. The goblin shark has a slingshot jaw. Its upper and lower jaws sit well back inside its skull in a retracted position. When it detects prey, a specialized ligament system catapults the entire jaw forward out of the face, extending several inches beyond the snout to grab whatever is in front of it. The strike happens faster than the human eye can track. We've known about the goblin shark since 1898. We have almost no footage of it alive in its natural habitat. Most specimens we've studied were caught in deep-sea fishing nets or found dead on beaches. It lives deep enough that direct observation is almost impossible.
The black swallower, Chiasmodon niger, a small deep-sea fish, usually around 25 centimeters long. It eats fish larger than itself, significantly larger, up to 10 times its own volume. Its stomach is expandable to an almost grotesque degree. The stomach walls stretch to accommodate prey that its body has no business containing. Photographs of black swallowers recovered from the ocean's surface show fish with something the size of a football bulging out of their abdomen, while the fish itself is barely the length of your hand. Here's the problem. When it eats something too large or too quickly, the digestive process produces decomposition gases faster than the stomach can handle. The gas builds up. The body becomes buoyant. The black swallower, mid-digestion, floats upward from the deep ocean to the surface, dead, still containing its meal. We have found more black swallowers at the ocean's surface than we have in their actual habitat. The only reason we know this species exists is because it occasionally eats itself to death and floats up to where we can find it. It kills itself through ambition, in the dark, 2 kilometers below the surface, and its corpse is its own discovery mechanism.
And then there's the Dumbo octopus, Grimpoteuthis, named after the Disney elephant because of the 2 large fin-like extensions on its mantle that it uses to propel itself through the water, flapping them slowly like wings. It lives deeper than almost any other octopus, up to 7,000 meters, the deepest living octopus we've ever found. It's small, rarely more than 30 centimeters. It drifts through the absolute darkness of the Hadal Zone, those enormous ear-like fins moving in slow, steady beats, hunting small crustaceans and worms on the ocean floor. It's the only octopus that swallows its prey whole, because at that depth, the pressure and cold mean it needs to extract as much energy as possible from whatever it catches, with as little expenditure as possible. It looks almost gentle. In an environment defined by pressure, darkness, and biological horror, the Dumbo octopus moves through the deepest parts of the ocean like something that wandered in from a children's book and decided to stay. We've explored less than 20% of the deep ocean. The giant isopod, the barrel eye, the siphonophore longer than a blue whale, the shark with the slingshot jaw, the fish that eats itself to death and floats to the surface, the octopus that flies through the deepest darkness on Earth with cartoon ears. All of that from 20%. Every time we send something down there, we find something that rewrites what we thought life could be. Something that breaks a rule we didn't know we'd made. Something that's been living in complete darkness at impossible pressure, eating impossible things for millions of years, without any awareness that we exist, or that we'd eventually find it. The deep ocean isn't empty. It's full of things we don't have names for yet.